Hello, welcome. Let's try to solve another Leetcode problem, 126, word letter 2. And this problem is just an expansion of the word letter 1. Although in Leetcode this should appear first. Yeah, but I don't know why 126 appeared first, but actually this question is much harder than 127. Yeah, but for me, I would like to solve the 127 first before solving this problem, because definitely this is much harder. Now I have the experience of 127. Now we just need to solve this problem. Yeah. So the descriptions is exactly the same, but the return gonna be different, because we want to return all the solid transformation sequences from the begin word to the end word, or an empty list if we don't have cannot find such kind of list. Yeah, and the list is going to be something like the begin word and then s1, s2 until sk. Yeah, and this sk should be equal to the end word. So this is the idea. So for this problem, as we are going to check all the different paths, it's not how many steps. Actually, it is about paths. Normally, if we are going to check the path, it's going to be a backtracking problem. Yeah, but before the backtracking, we can still use the BFS to check what is the. We can use this BFS to build a structure of how to use the backtrack. Because if we were to use the backtrack, we have to find a map structure. So for example, this word should map this word, and the dot should map the dot. Yeah, we need to find such a map, or we need to build an adjacency list for a graph problem for the backtracking. Yeah. And we can use this BFS to build such kind of structure. So similarly, it's going to be like word letter 1. We're going to start from a word, so for example, it is a hit, and then we're going to expand it. Yeah, so this is for the BFS. But while we are using this BFS, we're going to use this BFS to build a map. So I'm going to build a dictionary. So this dictionary is going to be an adjacency list, and this will be the add word to the begin word. Yeah, so for example, inside my adjacency list, for example, this is a cog, and for this cog, I'm gonna have a list. Maybe there are gonna be some other word, maybe I don't know, maybe log. Yeah, maybe log is inside. Yeah, so I'm gonna start to search from the cog, and then dog, and then maybe from others until I find the begin word, and finally I just need to reverse the list to get my final result. So actually there are two steps. The first step is similar like the word letter 1. We just need to use a BFS. And the second step is that we're gonna use the adjacency list we built from this BFS. Just use a backtracking to find all the different cases. Yeah, because in this way the time complexity gonna be just like 500 times 5. 5 is the length of the word, and 26 is the different cases. Yeah. So it's going to be 500 is the different word inside the word list. So this is why it is so fast if we are going to use the BFS and then directly backtracking. That is why we can pass. If we do not like to use this idea, basically we cannot pass it. Yeah. Now let's just use this idea to solve the problem. Yeah. So I think I want to copy and paste the solutions from word letter 1. So if you don't understand word letter 1, maybe you can check my videos to understand what it looks like, because basically I'm gonna use the same structure to solve the backtracking problem. Yeah. Now let me just copy it. So the structure is gonna be the same. First of all, I'm gonna turn this word list into a word set, and then I'm gonna check this word. Add word. If the add word is not inside the word set, definitely it is not impossible. So I'm gonna return an array. So here I'm gonna prepare an answer. So the answer is gonna be my final array. Yeah. Currently it's gonna be an empty array. Now this L is gonna be the length of the begin word, and S1 and S2 are gonna be a set. So from the begin word is gonna be inside S1, the add word is gonna be inside S2, and here I don't need to have this step because it is not necessary. But I need to prepare a map. It's gonna be before that I also need to prepare a flag. Yeah, let me explain this flag later. I will set the flag to false, and I'm gonna have a default index. It's gonna be a list, a adjacency list. Yeah. So let me explain this flag. So while we are checking this BFS, so for example, this is a layer by layer by layer. Maybe from here, this is the add word. Maybe it is a cog. Yeah. If we find this add word, we're gonna set this flag to true. This means to this layer, we've already found the end word. Yeah, but we should not stop it immediately from here. We should stop after finishing this layer. So after finishing this layer, it go to the next layer, and then we can stop it. Yeah, so this is the idea. I need to set a flag. Yeah, now let's just change something. Here we don't need to use this step, and for here we don't need to return the step. So if the word is inside S2, it means we've already found it. Yeah. So I'm gonna set this flag to true. Yeah. And for here, I need to break it. So if flag, because from here I set it to true, I need to break the while loop. Yeah, because for the BFS currently we don't have any return. If we don't have any return, we need to find a way to break the while loop. Yeah, because for the first example, if we find it, we can return immediately. Here we don't want to return immediately, so here we're gonna break it from the last layer if we find. Yeah, for this layer, if we find it after finishing this layer, so we're gonna stop it. So this is the idea. We have to stop the while loop. Now we didn't use this map. So for here, we're gonna use this map. So if the word is inside the word set, of course we're gonna put it inside the S. This is a temporary set for the next layer. And also we need to prepare this set. So it's gonna be the D word. So this is gonna be the last word. So we're gonna append this W as the previous layer. We need to append this previous layer for this word. Yeah. After that, we can directly use backtracking. Yeah. So here I'm gonna return an answer at the moment. What to do? I want to check this adjacency list. Check this map if the map is okay. Yeah, we get a raw answer. It is okay because we didn't get any return at the moment. But we just wanted to check if we really did get an adjacency list. So this is actually what we need. We just need to use this one. If we can get this adjacency list map, definitely we've already solved the problem. Why? Because we can start from the add word cog. So where is the cog? So this is the cog. Inside the cog, there's a dog and a log. So what about from the cog? We're gonna start from this dog, or we can start from this log. Yeah, we can start from any word if it is inside. So for example, this dog. Now we're gonna check this dog. It's gonna be a hot dog, dog. This is a dog, dog and dot, dog and dot. And what is gonna be the next one? Hot.